Good morning, students. Today I am going to take now the next part of group 13, 14, and 15 elements. The next part of group 13, 14, 15 element is test that is used to detect borate radical in qualitative analysis or action of concentrated sulfuric acid. This one. Action of concentrated sulfuric acid and ethyl alcohol on borax. Borax means Na2B4O7. When borax is heated with ethyl alcohol and concentrated sulfuric acid, it produces volatile vapors of triethyl borate. Borax, when heated with ethyl alcohol and concentrated sulfuric acid, it produces volatile vapors of triethyl borate, which burns with green aged flame. The volatile vapors of triethyl borate burns with green aged flame. Okay, the reaction is Na2B4O7 plus H2SO4 plus 5H2O gives Na2SO4 plus 4H3BO3. So borax on reaction with concentrated sulfuric acid and water, it produces sodium sulfate, that is Na2SO4, plus boric acid, that is 4HBO3. After the formation of boric acid, this boric acid, it is then reacted with ethyl alcohol, 3 moles of ethyl alcohol, this one. H3BO3, it is then reacted with ethyl alcohol, 3 moles of ethyl alcohol, it produces triethyl borate, that is BOC2H5 thrice. BOC2H5 thrice plus thrice of H2O. So this test is used as test for detection and removal of borate in qualitative analysis. Okay, so this is the reaction of sulfuric acid and ethyl alcohol with borax. Next one, uses of sorry uses of borax. What are the uses of borax? Borax is used to manufacture optical and hard borosilicate glasses. Borax is used in the manufacture of optical and hard borosilicate glass. It is used as a flux for soldering and welding. It is used as flux for soldering and welding. It is used as a mild antiseptic in the preparation of medical soaps. सोप्स बनाने के लिए भी बोरेक्स का इस्तेमाल किया जाता है. It is used as a mild antiseptic in the preparation of medical soaps. Next, it is used in qualitative analysis for borax bead test. In qualitative analysis, it is used for borax bead test. And last one, it is used as brightener in washing powder. वॉशिंग पाउडर में भी इसका इस्तेमाल किया जाता है. ओके, नाउ नेक्स्ट पार्ट, दैट इज सिलिकॉन्स. व्हाट आर सिलिकॉन्स? डेफिनेशन ऑफ सिलिकॉन्स. Silicons are organosilicon polymers having R2SiO repeating units. Silicons are organosilicon polymers having R2SiO repeating units held by S-O-S linkage. This is known as silicons. Here R is equal to methyl group or phenyl group, where R is equal to CH3 or C6H5 group. That is known as silicons. Once again, what is the definition of silicons? Silicons are organosilicon polymer. Silicons are organosilicon polymer where R is equal to having R2SiO, where R is equal to CH3 or C6H5 group as a repeating unit held together by Si-O-Si linkage. This is known as silicons. Okay, since the empirical formula R2SiO is similar to that of ketones having same general formula, that is R2CO. Since the empirical formula R2SiO is similar to that of R2CO ketones, these compounds are named as silicons. कीटोन्स को जैसे कहा जाता है वैसे ही इसे कहते हैं silicons, because of the empirical formula of silicons is similar to that of ketones. So that's why these compounds are named as silicons. Okay, now how are silicons prepared? Silicon कैसे बनाया जाता है? How are silicons prepared? Preparation of silicons. Alkyl or aryl substituted silicon chlorides having general formula. Alkyl or aryl substituted silicons chlorides having general formula RnSiCl in bracket 4 minus N, where R is equal to alkyl or aryl groups, are used as a starting material for manufacture of silicons. These starting material are NSiCl 4 minus N, where R is equal to alkyl or aryl groups. These groups are used as the starting material for the manufacture of silicons. Okay. When now the exactly preparation of silicons, when methyl chloride reacts with silicon, when methyl chloride reacts with silicons in the presence of copper catalyst at 573 Kelvin, when methyl chloride reacts with silicon in the presence of copper catalyst at 573 Kelvin, various types of methyl substituted chlorosilan of formula MESiCl3, Me2SiCl2, Me3SiCl with small amount of Me4Si are formed. When methyl chloride reacts with silicons in the presence of copper catalyst at 573 Kelvin, various types of methyl substituted chlorosilan, various types of methyl substituted chlorosilan of formula MESiCl3, Me2SiCl2, Me3SiCl with small amount of Me4Si are formed. So reaction यहाँ पर देखो क्या है, twice of CH3Cl. This is known as methyl chloride. CH3Cl means methyl chloride. Twice of CH3Cl plus silicon Si, arrow के ऊपर Cu, copper powder as a catalyst at about 573 Kelvin, it produces dimethyl dichlorosilan, that is Si, 2 methyl group और 2 chlorine सिलिकॉन को जुड़े हैं, उसे कहते हैं दिस वन Cl dash Si dash CH3 dash CH3 dash Cl. दिस इज नोन एज डाइमिथाइल डाइक्लोरोसिलैन. क्या नाम है इस कंपाउंड का? डाइमिथाइल डाइक्लोरोसिलैन. हाइड्रोलिसिस ऑफ डाइमिथाइल डाइक्लोरोसिलैन फॉलोड बाय कंडेंसेशन पॉलीमराइजेशन. Hydrolysis of dimethyl dichlorosilan followed by condensation polymerization yields straight chain silicon polymer. अभी इस कंपाउंड का हाइड्रोलिसिस करने के बाद, किस कंपाउंड का? डाइमिथाइल डाइक्लोरोसिलान ऑन हाइड्रोलिसिस followed by condensation polymerization, it gives straight chain silicon polymers. It gives straight chain silicon polymer, that is n numbers of, यहां पर दिया है हाइड्रोलिसिस Si-Cl-Cl-CH3-CH3 on hydrolysis it produces OH-Si-CH3-CH3-OH. This compound on hydrolysis it produces this addition compound. It is known as dimethyl disilandiol. Dimethyl disilandiol. Dimethyl silandiol. Okay, so this dimethyl silandiol on polymerization, this डाइमिथाइल सिलैंडायोल, इसका नाम नहीं दिया यहां पर, उसका नाम क्या है? डाइमिथाइल सिलैंडायोल ऑन पॉलीमराइजेशन इट प्रोड्यूसेस सिलिकॉन पॉलीमर. दिस इज द सिलिकॉन पॉलीमर. इसका पॉलीमराइजेशन करने के बाद वाटर मॉलिक्यूल निकल जाता है और बन जाता है सिलिकॉन पॉलीमर. ओके, सो द चेन लेंथ ऑफ पॉलीमर कैन बी कंट्रोल बाय एडिंग दिस चेन लेंथ ऑफ पॉलीमर. The chain length of polymer can be controlled by adding CH3 thrice SiCl at the end. This chain length, the chain length of polymer can be controlled by adding CH3 thrice SiCl at the end. यहाँ पर reaction दी है देखो. So this chain length of polymer can be controlled by adding CH3 thrice SiCl at the end as shown. So here CH3 dash Si dash CH3 dash CH3 dash O dash in bracket Si dash CH3 dash CH3 dash O dash Si CH3 CH3 CH3. Okay, so this polymer is known as silicons polymer. Okay, so this is the preparation of silicons. Now the properties of silicons. What are the properties of silicons? Silicons are water repellent. Silicons are water repellent. They have high thermal stability. Silicons have high thermal stability. They are good electrical insulator. Silicons are good electrical insulator, and silicons are resistant to oxidation and chemicals. Silicons are resistant to oxidation and chemicals. So these are the properties of silicons. Now the uses of silicons. Silicons are used as insulating material for electrical appliances. Silicons are used as insulating material for electrical appliances. Okay. Second one, it is used as waterproofing of fabrics. It is used as waterproofing for of fabrics. It is used as sealant. It is used as sealant. And next one, it is used as high temperature lubricants. As high temperature lubricant, it can be used as high temperature lubricant. Next one, for mixing in paints and enamels to make them resistant to high temperature, sunlight and chemicals. It is used for mixing in paints and enamels to make them resistant to high temperature, sunlight and chemicals. Okay, so these are the uses of silicons. Totally 5 uses are there. Now next compound is ammonia. पहला कंपाउंड हमने देखा बोरेक्स, सेकेंड कंपाउंड देखा है सिलिकॉन्स, अभी थर्ड कंपाउंड है अमोनिया. अमोनिया हैविंग केमिकल फॉर्मूला NH3. Now the preparation of ammonia. How is ammonia prepared from nitrogenous organic matter? How is ammonia prepared from nitrogenous organic matter, that is from urea? Nitrogenous organic matter means urea, from urea. So ammonia is formed by the decomposition of nitrogenous organic matter such as urea. Ammonia is formed by the decomposition of nitrogenous organic matter such as urea. It is therefore present naturally in small quantities in air and soil. वो एयर में भी होता है और सॉइल में भी होता है स्मॉल क्वांटिटी में. ओके, सो रिएक्शन इज हाउ इज यूरिया प्रिपेयर्ड. केमिकल रिएक्शन NH2CONH2. दिस इज यूरिया. Chemical formula of urea is NH2CONH2 on hydrolysis with water with 2 molecules of water. Urea on hydrolysis with 2 molecules of water, it produces ammonium carbonate, NH4 twice CO3. This is known as ammonium carbonate. And ammonium carbonate on decomposition, it produces ammonia 2NH3 plus water plus carbon dioxide. So this is urea twice of NH3 plus H2O plus CO2. This is NH3 is known as ammonia. This is the first method of preparation of ammonia. Second one, laboratory method for the preparation of ammonia. How is ammonia prepared in laboratory? So ammonia is prepared on laboratory scale by decomposition of ammonium salt with calcium hydroxide or caustic soda. Ammonium salt means ammonium chloride or ammonium sulfate. These are known as ammonium salt. NH4Cl, NH4 twice SO4. These are ammonium salt. NH4Cl is known as ammonium chloride and NH4 twice SO4 it is known as ammonium sulfate. When ammonium chloride is treated with calcium hydroxide CaOH twice, it is known as calcium hydroxide. When ammonium chloride is treated with calcium hydroxide, it produces ammonia 2NH3 plus calcium chloride and water. And when ammonium sulfate NH4 twice SO4 is treated with NaOH, alkali like NaOH, 2NaOH, it produces twice of NH3 plus Na2SO4 sodium sulfate plus water. So this is the laboratory method for the preparation of ammonia. Now preparation of ammonia by Haber process. Haber process, in this process large quantity of ammonia is prepared. On large scale ammonia is prepared by direct combination of dinitrogen and dihydrogen. This process is known as Haber process. How is ammonia manufactured by Haber process? So on large scale ammonia is prepared by direct combination of dinitrogen and dihydrogen by Haber process. In this process here, the theoretical part first of all, in this process dinitrogen reacts with dihydrogen under high pressure of 200 into 10 raised to 5 Pascal, that is 200 atm. 200 into 10 raised to 5 Pascal means 200 atm. Okay, so dihydrogen reacts with dinitrogen under high pressure of 200 into 10 raised to 5 Pascal or 200 atm and temperature around 700 Kelvin to produce ammonia. To produce ammonia, iron oxide with trace amount of potassium oxide and alumina Al2O3 is used as catalyst. यहाँ पर catalyst इस्तेमाल क्या किया है? Iron oxide FeO or Fe2O3, iron oxide with trace amounts of K2O, that is potassium oxide, and Al2O3, that is aluminum oxide, is used as catalyst in Haber process. हैबर प्रोसेस में प्रेशर कितना इस्तेमाल किया जाता है? 200 एटमॉस्फेयर. 200 एटमॉस्फेयर. टेम्परेचर कितना इस्तेमाल किया जाता है? द टेम्परेचर रिक्वायर्ड, ऑप्टिमम टेम्परेचर यूज फॉर हैबर प्रोसेस इज 700 Kelvin. Optimum pressure used for Haber process is 200 atmosphere, and the catalyst used in Haber process is iron oxide with trace amounts of K2O and Al2O3 is used as catalyst in Haber process. Okay, high pressure फेवर्स द फॉर्मेशन ऑफ अमोनिया. प्रेशर हाई इस्तेमाल करने की वजह से अमोनिया बन जाता है. हाई प्रेशर फेवर्स द फॉर्मेशन ऑफ अमोनिया एज इक्विलिब्रियम इज अटेन रैपिडली अंडर द condition, under this condition. Okay, so what is the reaction? Haber process, here N2 gas plus 3H2 gas, 3 हाइड्रोजन यहाँ पर गलत दिया है, 3H2 लेना है. N2 gas plus 3H2 gas gives 2NH3 and the reaction is highly exothermic because of large amount of heat is evolved. How many heat is evolved? Minus 46.1 kilojoule per mole heat is evolved during the formation of ammonia. So that's why this reaction is exothermic reaction. Okay, now physical properties of ammonia. What are the physical properties of ammonia? First one, ammonia is a colorless gas with pungent odor. This is the first physical property. Second one, it has freezing point of 198.4 Kelvin and boiling point of 239.7 Kelvin. What is the freezing point of ammonia? 198.4 Kelvin and boiling point is 239.7 Kelvin. It is highly soluble in water. Ammonia is highly soluble in water. Okay, so these are the properties of ammonia. Now, what is liquor ammonia? What is meant by liquor ammonia? Definition of liquor ammonia: the concentrated aqueous solution of ammonia, that is NH3, is called liquor ammonia. The concentrated aqueous solution of NH3 is called liquor ammonia. Okay, so that is the definition of liquor ammonia. Now, next one, give reason. Ammonia has higher melting point and boiling point. Ammonia has higher melting point and boiling point. Why? Because of ammonia produces intermolecular hydrogen bonding. The large number of ammonia molecules are associated with intermolecular hydrogen bonding, and large amount of energy is required to break this hydrogen bond. So that's why ammonia having higher melting point and boiling point. So यहाँ पर दिया है रिमेंबर में, ammonia has higher melting point and boiling point because in the solid and liquid state ammonia molecules get associated through hydrogen bonding. Thus, some more energy is required to break such intermolecular hydrogen bonds. So that's why ammonia having higher melting point and boiling point. Okay. Now, why is ammonia basic in nature in aqueous solution? In aqueous solution, ammonia shows basic nature. Basic nature of ammonia, because of as ammonia is highly soluble in water. अमोनिया वाटर में हाईली सोल्यूबल होने की वजह से, एज अमोनिया इज हाईली सोल्यूबल इन वाटर, it readily forms OH minus ions. Which solution is known as basic solution? The solution which produces OH minus ions are known as basic solution, and the solution which produces H plus ions are known as acidic solution. Acidic solution means जिस सॉल्यूशन में H प्लस आयन बन जाते हैं, एक्वियस सॉल्यूशन में H प्लस आयन जो बनाता है उसे कहते हैं एसिडिक सॉल्यूशन, और एक्वियस सॉल्यूशन में OH माइनस आयन जो बनाता है उसे कहते हैं बेसिक सॉल्यूशन. सो एज अमोनिया इज हाईली soluble in water, it readily forms OH minus ions in its aqueous solution. That is the reaction. NH3 gas plus H2O liquid gives reversibly NH4 plus aqueous plus OH minus ions. So due to the formation of OH minus ions in its aqueous solution, ammonia is basic in nature. Thus, due to the formation of OH minus ions, aqueous solution of ammonia is basic in nature. Okay, so this is the basic nature of ammonia. Now, what is the action of ammonia on dilute hydrochloric acid and sulfuric acid? When ammonia reacts with dilute hydrochloric acid, it produces ammonium chloride. Ammonia NH3 when reacts with HCl, it produces ammonium chloride. And when ammonia reacts with dilute sulfuric acid, it produces ammonium sulfate. So twice of NH3 plus H2SO4 gives NH4 twice SO4. Okay. So this is the chemical property. Now what is the action of aqueous solution of ammonia on following salt solution? Which salt solution? Zinc sulfate salt solution and ferric chloride salt solution. What is the action of aqueous solution of ammonia on following salt solution? So zinc sulfate and ferric chloride. So aqueous solution of ammonia when reacts with salt solutions, they form precipitate of hydroxides of metals. Aqueous solution of ammonia when reacts with salt solutions, they form precipitates of hydroxides of metals or hydrated oxides of metals. So reaction is zinc sulfate ZnSO4 aqueous solution when reacted with NH4OH, that is ammonium hydroxide, it produces ZnOH twice plus NH4 twice SO4 ammonium sulfate. Zinc sulfate when reacted with ammonium hydroxide, it produces zinc hydroxide, that is white PPT, white precipitate plus ammonium sulfate. And when ferric chloride is treated with ferric chloride twice of FeCl3 when treated with 6NH4OH, when twice of FeCl3 when treated with 6NH4OH, यहाँ पर टेक्स्ट बुक में गलत दिया है, ट्वाइस ऑफ NH4OH दिया है, मैंने यहाँ पर 6 बताया, देखो करेक्शन कर लो. Twice of FeCl3 plus 6NH4OH gives Fe2O3 3H2, X की जगह पर 3 लिखना है, Fe2O3 3H2O plus 6NH4Cl plus 6NH4Cl. X दिया है यहाँ पर और Y यहाँ पर 6 बन गया. X कौन है? X means number of water molecules and Y means number of ammonium chloride molecule. So 2 FeCl3 करेक्शन कर लो यहाँ पर. FeCl3 कितना लेना है? 2 FeCl3 plus 6NH4OH gives Fe2O3 3H2O plus 6NH4Cl. So this is the reaction of aqueous solution of ammonia with salts, zinc sulfate and ferric chloride. Next, ammonia is good complexing agent. Why ammonia is complexing agent? Because of it produces ammonia produces complex compound, complex formation reaction. Ammonia is a good complexing agent because of the lone ammonia nitrogen atom containing a lone pair of electron. अमोनिया में जो NH3 है, NH3 के ऊपर NH3 में जो नाइट्रोजन है, नाइट्रोजन के पास एक लोन पेयर होता है, वो नाइट्रोजन लोन पेयर डोनेट करता है और कॉम्प्लेक्स कंपाउंड बनाता है. सो अमोनिया gives a brown PPT with lone pair of electrons on nitrogen atom, lone pair of electron on nitrogen atom felicitate complexation of ammonia with transition metals. Ammonia reacts with transition metal, it produces complex compounds. Thus ammonia is a complexing agent as it forms complex by donating its lone pair of electrons. Once again, complex formation reaction. The lone pair of electrons on nitrogen atom felicitates complexation of ammonia with transition metal ions. For example, यहाँ पर example दिया है copper ions, Cu plus 2 ions, which is blue in color. When it is treated with 4NH3 ammonia, it produces deep blue color complex compound, that is Cu NH3 4 times 2 plus. When blue colored cupric ion, यहाँ पर color नहीं दिया है. When blue colored cupric ion Cu plus 2 ion reacts with ammonia 4NH3 aqueous solution of ammonia, it produces deep blue colored copper tetraamine complex CuNH3 2 plus ion. And when ammonia, aqueous solution of ammonia, reacts with white colored silver chloride, AgCl is white in color. So AgCl when treated with 2NH3 aqueous, it produces colorless complex compound, that is AgNH3 twice Cl. Okay, so this is the complex formation reaction by ammonia. Next one, नेस्लर रिएजेंट टेस्ट. नेस्लर रिएजेंट टेस्ट यहाँ पर है, आखिरी यूजेस है, वो यूजेस बाद आखिरी में देखेंगे. नेस्लर रिएजेंट टेस्ट येलो कलर के इसमें दिया है, रिमेंबर. So Nessler reagent, ammonia gives brown PPT with Nessler's reagent. What is Nessler's reagent? Nessler's reagent का preparation है K2HgI4. It is known as Nessler's reagent. Ammonia gives brown PPT when with Nessler's reagent. Nessler's reagent is an alkaline solution of K2HgI4. Nessler's reagent is an alkaline solution of K2HgI4 and it is prepared as, उसका preparation कैसे दिया है देखो, 2Ki plus HgCl2. Ki means potassium iodide, HgCl2 means mercuric chloride. 2Ki plus HgCl2 gives mercuric iodide HgI2 plus 2KCl potassium chloride. After the formation of HgI2, this HgI2 it is then reacted with excess of Ki. Again Ki is reacted with HgI2, it produces K2HgI4, that is Nessler reagent. And when Nessler reagent is treated with ammonia, alkaline solution of ammonia, alkaline solution twice of K2HgI4 plus NH3 plus 3KOH, it produces million base, that is brown PPT of million base, that is NH2-HgO-HgI. This is known as brown PPT, millions base of brown PPT, plus along with 7Ki plus 2H2. Okay, and this is the reaction of Nessler reagent with ammonia. When ammonia reacts with Nessler reagent, it produces brown PPT. Okay, and uses दिया है, वो uses पढ़ो आप. Okay, this is the end of lesson number 9, that is group 13, 14 and 15. ओके, अभी स्टेट्स ऑफ मैटर हमने शुरू किया था, शुरू का पार्ट था थियोरेटिकल पार्ट, तो वो हम कल देखेंगे. ओके, थैंक यू.